Hi, this is Tim and welcome to the Mathly YouTube channel. Today we're going to be talking about problem number 28 from sprint round 12113. Now remember, this is a middle school contest, and so I should mention that even though there are plenty of opportunities where calculus would come in handy on this problem, I'm going to use a solution that assumes that you don't know calculus. I'm also going to use a solution that assumes you don't know the AM-GM inequality. Now, if you've looked at the solution that came with this test, you'll see that it takes advantage of the AM-GM inequality. If you're not already familiar with that, I definitely encourage you to look it up and then take another look at the written solution to see if the solution as written makes sense. However, I'm going to take a different approach today and show you a little bit different way to do this one. So we got two numbers that add up to 1, and we need to know the maximum value if you cube one and multiply it by the square of the other. All right, so the first thing you might be thinking is, oh, well, x cubed, that's, going to be the bigger number. So maybe I should make x as big as possible, make it a 1. The problem there, of course, is that y becomes 0 and the whole product is 0. Or you might be thinking, hey, if I've got a number less than 1, which x and y have to be, obviously, I don't want to cube it. I want to make the cube as small as possible. Of course, if you make x equals 0 and y is 1, then you also get 0. We are looking for the maximum possible value of this thing. So the question is, can we do better than 0? Well, obviously we can, right? If we just let x and y both equal a half, then we've got 1/2 to the 5th power, which is 1/32. Okay, can we do better than that? So your first thought on this problem, right, from a strategic standpoint is, okay, 1/2 would be, setting them both equal to 1/2 and getting 1/32 as an answer would be too easy, right? So there's got to be a trick to it. Okay, so what we want to do is ask ourselves, okay, if we change things around a little bit, can we do better than 1/32 as a final answer? Well, in order to kind of hypothesize a solution, what I'm going to have you look at is the exponents of x and y. And you might think to yourself, well, what if we were to set up x and y in proportion to their exponents, right? So in other words, what if we were to, for instance, let x equals 3/5 and y equals 2/5, right? So we've got them in a 3:2 ratio, but they still add up to 1. Okay, if that happens, then we're going to be able to plug this in and get x cubed is 27/125, y squared is 4/25, and the total result is 108/3125. Now, this is bigger than 1/32, right? 1/32 is the same thing as 100/3200, but since this numerator is larger than 100 and the denominator is less than 3200, this number is definitely bigger than 1/32. So we have a better answer at that point. Now, here's the fun part. When you take a look at test-taking strategy, this might be where you want to stop, right? If you don't have a solid plan for coming up with something better, with spoiler alert, there isn't, and I'll show you why in just a moment. But if you also have an idea for how you can prove this, but find that it will take too long, and you be the judge of that after watching this video, you may want to just go ahead and write this down as your answer and move on without verifying it. However, if you're interested in seeing why this is the best possible solution, keep watching. All right, so here's the deal. We've got a value for x cubed, y squared that looks pretty decent. The question is, can we do any better? Well, if x is 3/2 and y is 2/5 is going to give us a particular number, the question might be, what if we deviated a little bit, right? What if we added a little bit or subtracted a little bit from x and then, of course, changed y accordingly? Can we do any better? So that's actually what I'm going to explore here. In particular, let's say we're going to add a small number a to the numerator of x. Then, of course, we subtract the same a from the numerator of y. Now, I should point out here that a could be positive or negative, right? I mean, it's possible that we increase x a little and decrease y, or maybe we decrease x and increase y. There are some constraints on a, however. Okay, first off, we don't want a to be 0 because that doesn't do any better. That just gives us the same answer back. The thing is, x and y both have to be positive numbers. So that does put these constraints on our value for a, okay? In particular, because x is 3 plus a, we can't let a be less than -3 or x becomes a negative number. We can't let y be greater than 2 or y becomes a negative number. So at this point, we do have some constraints on a that we'll have to double check as we go along. But if x is 3 plus a over 5, and y is 2 minus a over 5, then what does that give us? Well, it gives us this, x squared times y cubed equals, and you can multiply this out to verify it on your own. We get this monstrosity here. We've got a cubic polynomial over 125, that's your x cubed portion. We have a quadratic polynomial over 25, that's your y squared portion. Now, what we want to do is go ahead and multiply those out, and we get something that looks like this. All right, so now we have a 5th degree polynomial all over 3125. That's what we get when we plug in 3 plus a over 5 and 2 minus a over 5 for x and y. Remember, the question was, can we do better than 108 over 3125? In other words, is this greater than 108 over 3125? Well, we can do a couple of things first. Notice that there is a denominator of 3125 on both sides of the equation. Let's multiply both sides by that. Then you'll see there's a 108 on both sides. Let's subtract a 108 from both sides, and you'll see that we have this inequality. Now, you'll notice I've put a question mark here, right? So the question mark is asking a question. It's a yes or no question, which relates back to the question, can we do better? All right, we're going to find out either yes or no, we can do better. And if the answer is no, then we keep our answer of 108 over 3125. Okay, a to the 5th plus 5a to the 4th minus 5a cubed minus 45a squared is greater than 0. Can that happen given the bounds that we have on a? Well, let's make this a little bit simpler, of course. So next up, I want you to notice that we can factor out an a squared from the left-hand side of the equation. Now remember, we stipulated already that a is not equal to 0. And remember, if a is not equal to 0, then when we square it, we definitely get a positive number. What that tells us is we can divide both sides of this inequality by a squared. I'm going to do that, and then I'm also going to add 45 to both sides. So the question reduces to this. Can we find a in the range that we've identified already, such that a cubed plus 5a squared minus 5a is greater than 45? All right, so this is going to actually split into two cases, right? So we have, we're going to test the positive values of a first, and then we're going to test the negative values of a. So case 1, a is strictly between 0 and 2. Now, if a is between 0 and 2, then that tells us something about each piece of this cubic that we have, right? We're taking a look at this cubic, asking, can it be bigger than 45? Well, if a is between 0 and 2, a cubed is definitely less than 8. If a is between 0 and 2, then a squared has to be between 0 and 4, and 5a squared has to be between 0 and 20. In particular, 5a squared is less than 20. Now, what about the minus 5a part of this cubic, right? The part that we see right here. Well, if we take all the values from 0 to 2, then we know that negative 5a, first off, it's always going to be a negative number, right? So negative 5a is definitely less than 0. So what we're going to do then is add the left-hand sides and the right-hand sides of all these inequalities. Notice that the inequalities are all pointing in the same direction, so we can add inequalities together anytime we have them pointing in the same direction. So on the left-hand side, of course, I get a cubed plus 5a squared minus 5a is less than 28. Okay, so wait a minute. We were trying to figure out, can a cubed plus 5a squared minus 5a be greater than 45? And we just found out it has to be less than 28. So the answer is no, it cannot be greater than 45, right? So again, we asked ourselves, can we do better than this answer? Well, it turns out that by modifying x and y, by adding a little bit to x and subtracting a little bit from y, in other words, that's this part right here where a is between 0 and 2, no, we can't. So then we move on to case number 2, the other possibilities for a, where a is a negative number between negative 3 and 0. In other words, we're going to be subtracting something from x and subtracting a negative number for y. We're going to be adding something to y, right? Can we subtract something from 3/5 for x and add that corresponding portion to 2/5 for y and do any better than this answer? Well, let's find out. So first off, I've got this negative 5a part of my cubic that's going to be less than 15, right? The reason is because this right here tells us that a is greater than -3. Multiplying both sides by -5, we flip the inequality, we get -5a is less than 15. All right, what about the a cubed plus 5a squared part? First thing you might want to think about is, well, what if a was -3? Now remember, a can't be -3. It's got to be greater than -3. But if we let a equal -3, then we find out that a cubed plus 5a squared is -27 plus 5 times 9, 45. -27 plus 45 is 18. All right, but we want to know if we can do better than that. Can we get anything higher than 18, in other words? Well, in order to do that, we're going to use pretty much the same trick that we used up here when we said, can we do better? Right? We say, okay, well, if I plug in certain values into a polynomial equation, I can test if I can do better by modifying those values a little bit. So can I do better than this? Well, if I put a all the way down to -3, basically what I'm looking to do is add something on to the -3 in the positive direction that keeps a negative number, right? So in other words, I want a to stay between -3 and 0. So I'm going to be able to add any number from 0 to 3 onto a and see what happens. So what we're going to do then is replace our a with -3 plus b. Okay, so we're going to take that -3 that would have given us an 18 and say, hey, what if I add a positive number onto it, something between 0 and 3 to keep a negative number. But what if I add that on? Can I make that greater than 18? Well, let's go ahead and multiply this out and see what happens. All right, you do all the multiplication, you get b cubed minus 4b squared minus 3b plus 18 greater than 18. Can I make that happen? Well, let's take a look. First off, let's subtract 18 from both sides. That just makes it a little bit easier. And then I guess the next step would be I can factor out a b from this. I know that b is positive, and so if I divide both sides by b, I actually end up with a quadratic. We can deal with a quadratic, right? So what have we got? B squared minus 4b minus 3. Can that be greater than 0? Well, the way to test that out is to find the roots of b squared minus 4b minus 3. And it turns out that the roots occur at 2 plus or minus root 7. You can use the quadratic formula to figure that out. So I've got this parabola, right? B squared minus 4b minus 3 equals 0. Right? And you know the shape of that parabola. It's going to have zeros at 2 plus root 7 and 2 minus root 7. Okay. Now, just want to be clear here. Root 7 is between the square root of 4 and the square root of 9. In other words, it's between 2 and 3. So it's 2 point something. So one root is 2 plus 2 point something. That's bigger than 3. The other root is 2 minus 2 point something. That's less than 0. So my two roots are going to be higher than 3 and lower than 0, and everything in between, including the whole interval from 0 to 3, is going to be less than 0. All right, so when b is between 0 and 3, b squared minus 4b minus 3 has to be less than 0. So we were asking ourselves, though, can b squared minus 4b minus 3 be greater than 0? And of course, the answer is no. So that answers this question. Can we do better than 18 by adding, instead of plugging a -3 into this, can we add something onto it and do better? No, we can't. 18 is the upper bound for what we can get from a cubed plus 5a squared within this, within the range of a from -3 to 0. So because that's the case, we can now put 18 in as a maximum value for a cubed plus 5a squared. We can put 15 in as a maximum value for -5a, and that gives us that a cubed plus 5a squared minus 5a is less than 18 plus 15, right? The 18 coming from here and the 15 coming from here. This, of course, is 33. A cubed plus 5a squared minus 5a is less than 33, which means that it can't be bigger than 45, right? So we already determined that taking x equals 3/5 and y equals 2/5 and adding something to x and subtracting something from y, that can't do any better than our original 108 over 3125. Turns out that a negative value of a between -3 and 0 also will not allow us to do any better than 108 over 3125. So what does that mean? Well, that means 108 over 3125 is the best we can do. It's the maximum value, and that's going to be our answer. And that's how it's done. Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.